We're going to be looking at Pascal's triangle and binomial theorem. They are connected together in that you have to use Pascal's triangle in order to use the binomial theorem. Okay, so Pascal's triangle, real brief, it starts off with a 1 and then a 1, 1. This is considered line 0, line 1, line 2. We have 1s all along the diagonals of the triangle, and then to get the middle numbers, what you're going to do is you're going to take the 2 above it and add them together to get you 2 here. For line 3, again, 1s are on the diagonal. I combine my numbers above it and I add those in order to finish my line. So notice in line 3, I've got 4 numbers, but it starts off with a 3 there. So line 4, again, 1s along the diagonal. Add these together to get me 4, 6, and 4. So every time you're just adding those numbers. The line number tells you it goes 1 and then that line number, and then from there you're going to have to keep expanding. So these numbers are going to be beneficial for our binomial expansion. I could keep going with line 5, line 6, etc. It just keeps going on forever and ever here. But with that, say for instance, and it's actually almost easier if I just show you an example of the binomial theorem. So we'll expand using binomial theorem. And I'm going to have x plus 2 to the power of 4. So what I'm doing is I'm going to use the binomial theorem, which is basically just an expansion of Pascal's triangle. So this little 4 here, my exponent, tells me what line of Pascal's triangle I need to use. So I'm using Pascal's triangle line 4. Okay, this is the exponent where you're looking for it. So I'm going to give myself some space here. So if I look at Pascal's triangle, line 4, I have 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Again, give your space between those numbers. Now, I'm going to use the x's, and the x's are going to have the exponent will descend. Okay, so that might not make sense right now, but it will. I have x to the, my degree was 4, x to the 4th power, x to the 3rd, x squared, x1, x0. And the last one, exponent will ascend. So I have 2 to the 0, 2 to the 1st, 2 squared, 2 cubed, 2 to the 4th. So in between each one of these, I've now kind of set it up and there's a pattern there. So the red numbers deal with the exponent, the original exponent in Pascal's triangle, whatever line that is. The x is the first number or first term that I'm expanding, and it goes, the exponent descends in order. The last term, that 2, is going to have the exponents ascend. So now I actually need to simplify this. Well, 2 to the 0 is 1, so I have 1 x to the 4th. 2 to the 1st is 2 times 4 gives me 8, a positive 8. So I have plus 8 cubed. 8x cubed. In the middle here, I've got 2 squared times 4 to give me 24, positive. My next term, I've got 2 cubed gives me 8. 8 times 4 gives me 32. I don't have to list it to the 1st power, so I'm just going to leave it there as a regular x. X to the 0 is 1, so I have 2 to the 4th gives me 16. I just now expanded this using the binomial theorem in Pascal's triangle. Now you might be asking yourself, why would I want to use this over distribution? If you're looking at distribution, you'd have to technically list this x plus 2. You don't need to write this down, by the way. Sorry. You'd have to list the x plus 2 4 times and then do this distribution, get an answer, and then follow into that distribution. There's so much distribution that it's almost easier to use Pascal's triangle and the binomial theorem in order to expand it because there's a pattern there. Now, we're going to do another one of these, but I'm going to make it so it's a little bit trickier for us to look at. I'm going to have 2x minus 3 to the 3rd power. Okay, so again, this little 3 here, my exponent is going to tell me what line of Pascal's triangle I'm going to use, which I'm going to have 1, 3, 3, 1. 2x is my first one. Notice I'm listing this in parentheses. We're descending in order, so 2x cubed, 2x squared, 2x to the 1st, 2x to the 0, and then that negative 3. I am ascending in order. And then I have my breaks in between. So now I need to simplify this. So this is technically gone, so I don't need to list it. 2 cubed gives me 8. So this little 3 here goes to everything inside those parentheses. So I get 2 cubed gives me 8 times 1 gives me 8. Now this one I have a couple different numbers. I'm going to do the squared first. So 2 squared gives me 4. 4 times this 3 gives me 12. 12 times this 3 gives me negative 36. 2 to the 1st gives me 2. 2 times 3 gives me 6. 6 times 9 gives me 54. Because it's negative and it's squared, it's a positive 54. 2x to the 0 is technically gone. So I have negative 3 cubed, which is going to get me negative 27. So it gets a little bit more challenging when there's a number, 2 different numbers, and you have a negative. So you have to be careful with those positive negative signs. So this is binomial expansion using Pascal's triangle.